So today we will talk about the theory side or the description verbal side of this, the data analysis, which is taken out from a book called Introduction to Data Analysis. So what we will discuss about includes what is data, and then we will talk about qualitative versus quantitative data and data strategies. And then I will talk about some examples of different data strategies, such as visualizing the data, exploratory analysis, trend analysis, estimation, and then we will talk about what is data analysis. So next is, what is data? The data, this is the definition taken out from Merriam-Webster.com. So data means there are three descriptions or definitions for the word data on this website or dictionary. The first one is factual information, such as measurements or statistics, used as a basis for reasoning, discussion, or calculation. The data is plentiful and easily available. So this the second definition is information in digital form that can be transmitted or processed. And the third definition is information output by a sensing device or organ that includes both useful and irrelevant or redundant information and must be processed to be meaningful. So if we include all of these, and then basically it's information. The data is information, right? Those are the word. That's the word that we see in all of the three cases. Information. And information would normally be factual, like information that we can gather or observe. Those are the data. And this can be gathered from measurements or statistics, or it could be, like in the description number 2, is in a digital format that can then be used to can be transmitted or processed. For the factual information, that is gathered from measurements or statistics can be used as a basis, or the information can be used for making reasoning or discussing something or calculating something. Then the third definition, information output by a sensing device. So basically all three of these definitions just talk about different ways of getting the information. The first one is by observing or measurement or statistics or calculation. Then the second one is obtained in a digital form. Then the third one is you can obtain some of the information from a sensing device, or such as temperature, thermometer. That's a sensing device, or the device that senses the vibration of the earth, or earthquakes, something like that. And by data, it can be redundant, it can be not useful, just any kind of information, and it needs processing to get meaningful, to be meaningful. So Yeah, in summary, the definitions of data is basically it could include numbers, characters, images, or other method of recording in a form which can be assessed to make a determination or decision about a specific action. Um, so in like usually it's very logical that data on its own, like when we see data, we can't really like it doesn't have a meaning to it unless we process it or we interpret it to make it into a meaningful or transform it into a meaningful information. So that is what is required is close examination of the data to find patterns to perceive information, and then the information can be used to enhance knowledge. Next, there are like we can categorize the data into two types that are qualitative data and quantitative data. So qualitative data is the data that is represented either in a verbal or narrative format and is um, they can be collected through focus groups, interviews, open-ended questionnaire items, and other less structured situations. Like by less structured mean it's less structured than the quantitative data. So a simple way to look at qualitative data is anything that's not numbers. It is usually in the form of words. So example, just take a look at this for a bit. So what do you think this is? So it looks like an interview or conversation between the husband, wife. Like it's an interview about how each family feel about the Head Start program, which is primary school educational program in the States. And then they were talking about something about immigration, I think. So this is like an interview of the parents of like a kid in school, just kind of to know about the background of that family from what I can see from here. And they talk about like where the family came from and so on. So another category of data is quantitative data. Quantitative data is data that is expressed in numerical terms, in which the numeric values could be large or small. Numerical values may correspond to a specific category or label. An example, sample of quantitative data from PIR, which is again related to the Head Start program, is program informational report, I think. So it says actual enrollment by child, number of children enrolled in the program, and then it's separated by the ages. Under 1 year is 3,843. 1 year old is 4,785. And then 2 years old, there are 6,341 students enrolled. 3 years old, 7,604. 4 years old, 6,988. 5 years and older is 3,462. Contrasting types of data in Head Start, they are just comparing the qualitative and quantitative data. Again, just go back to this is the qualitative data. It's like in the form of interviews and text, like letters. And then this one is quantitative number. Quantitative data which has some form of numbers. Of course, there's some words to describe what the numbers are about. So qualitative data that can be extracted from the first set is basically it involves about family partnership agreements. This is for like there would be much more from about Head Start that is not shown here. And then there's data about social service logs, like the records of social service done for the family. And then advisory group minutes, which is like the recording of meetings. Policy council minutes, newspaper articles. So these are like articles, words, letters, recording in words. Then the quantitative data will include information from PIR, such as the table above this one. And then child performance tracking, which would be in terms of the number, like maybe the grades or like the milestones recorded in numbers. And then health data tracking systems such as weight, height. And then so that could be qualitative data, quantitative data, and in many cases the data are mixed, like it's partly qualitative, partly quantitative, such as enrollment info. Enrollment and transition records just has like a big file of all the information about a student, which includes both qualitative and quantitative. And then surveys. In the surveys, that could be an interview, which is qualitative. And then it could be like numbers, recordings, or like the income of the family, which would then be quantitative. And then teacher, staff, the number of teachers, farmers, whatever. So yeah, these are examples of different types of data. So we have the data side. We knew what data is. Now there's the word of analysis, data analysis. So what is data analysis? Basically, data, as we have discussed before, if we don't do anything about it, It's just information and it doesn't tell much. There's not much information or use that we can do unless we do some analysis on it. So data analysis is a process that includes the following components: purpose, questions, data collection, data analysis, procedures and methods, interpretation, identification of findings, and writing, reporting, dissemination, and evaluation. So we'll talk about data strategies or strategies used in doing data analysis. So data strategies, it means organized approaches to work with data, and this would then lead to create logical sequence for the use of different procedures. Data strategies provides analysts with an organized approach to working with data and enable the analyst to create a logical sequence for the use of different procedures. So this is what data strategies are. So examples of data strategies for quantitative analysis: if we have the data in terms of numbers or quantities, which are quantitative data, we have different strategies, which is, this is just pretty, let's say, most of the time we will be dealing, or we will prefer to work with quantitative data. It's easier to work with than the qualitative data. So the first strategy is to visualize the data. Data visualization involves creating a visual or picture or graphic display of the data. Why do we need to visualize the data? Well, if you see a bunch of number in written in rows or lines, it's going to look like text, and it's going to be very difficult to extract information or to draw any conclusions from it. So, in other words, we need a way to begin the analysis process or as an aid to the reporting, presentation of findings. So visualizing is the best way to give people kind of like the concept or the picture of what the data they are working with looks like. For the mind to be able to rationalize and absorb and make sense of the information, we need visualization. The next strategy is exploratory analysis. This one involves looking at the data to identify or describe questions like what's going on, and then creating an initial starting point or the baseline for future analysis. So this is pretty much the name explains what it is, exploratory. So we are exploring, looking at the data and explore it to make sense of what's going on, and then try to figure out the starting point to do further analysis. So why do we need this step? Well, basically, when you just get the data that is just so messy, and then like it's just for example, if it's a new thing that you just get a set of data or numbers or like a report with information, and then you were like, what can I do with this? So you need to start from exploring. So basically that's what it says, like you have a choice. We don't have a choice. We have to start exploring. Then the next strategy is trend analysis. It could be, in some cases, it doesn't really apply to like all the cases. Like the trend, what is a trend? A trend is like whether it has a pattern or not. Is it increasing? Is it decreasing? Is it fluctuating over time? It involves looking at the data collected at different periods of time. So trend would involve two axes of information, like two dimensions. One would always be the time, and the other one would be the other measure that we would work with. So why do we need this? Is in case that the data that we are looking at is related to time, or is time sensitive, or it changes over time. So we want to be able to identify and interpret and potentially estimate the change or how time affects the data. Or what is the relationship between the data and time? So that is what trend analysis is or involves. Now, next strategy is estimation. So another word could be forecasting, but in this sense, it's just like a simple forecasting, estimating the future, predicting what would the actual data values for the future be like. So this is just when we work with data, we would want some insight from it. And one of the most useful tool or insight that we can develop from the data is, what would it look like in the future? So then we could use prediction, estimation, or forecast. So those are just like a brief description of the different strategies, different data strategies for quantitative analysis. Then next we would talk about each of these in more details. So the definition of visualizing data is literally meaning to create and then consider a visual display of the data. So technically, it's just a way of displaying the data. It's not yet the analysis part, nor is it a substitute for analysis. Visualizing is just a tool or the step that you turn the data, which is written in numbers or text format into a visual display is a very useful starting point prior to analysis of the data. So consider the example, someone who is interested in understanding migrant and seasonal Head Start from a national perspective. Specifically, someone might be interested in the differences in funded enrollment across the MSHS grantees. It's the Head Start program. So looking at a random list of funded enrollment numbers from the data of PIR will give us some perspective. In a random order, it would be difficult to get a handle on the interpretation of the data. So if the data is presented in a random format, we will have a hard time understanding or making analysis from it. So then it leads to the need to rank the values in order, for example, like ascending or descending order, or lowest to highest, or highest to lowest. Then by ranking the number and putting it in a better visualization, we can get a more organized perspective of the data set. So example, on the first column is the random list. It looks very scattered. So this just looks very scattered. You cannot really make any relations on it. And then if we rank it according to ascending or rising value, then it looks more ordered, more organized, and then you can kind of see make relations with all the numbers. And then even more better visualization than just the number is to turn it into a chart, like a graph, or this one is the bar chart or his bar chart in ascending order. So this would be the number of children enrolled by grantee. So we have the numbers for grantees, and then the number of children enrolled. So that is there are many other ways to do visualization, we can make a bar chart, a scattered plot, a pie chart, and tree map chart, and many other things. It just depends on there are also the map, which we have been doing in Tableau. It's different kinds of visual will be appropriate for different kinds of analysis or data. We just have to be able to think and evaluate what kind of visual would be helpful or desirable for the case of our data. Like, what do we want to answer? What kind of questions are we looking at? For example, from this chart, you can see that as the number of grantees increases, the number of children enrollment also increases. So this is just in the increasing order of the grantee, and then we see that the number of children enrolled also increases accordingly. So this kind of gives us some insight on the data. Next is exploratory analysis. So the word explore is just to explore, to look for a pattern or for some insight that can be drawn. Exploratory analysis entails looking at the data when there is a low level of knowledge about a particular indicator. Examples are teacher qualifications. We don't really know how we would evaluate or compare teacher qualifications. There may be many different aspects to it. Then when we get the data or a set of data, we would have to look through it and do some exploratory analysis. Another example would be first and second language acquisition, and so on. So these data are like, it's not as a clear cut as in the number, as in that examples previously with the number of enrolled students versus the number of grantees, because there may be many aspects to the indicator. So exploratory analysis could also include the relationship, like exploring the relationship between more than one indicator or different indicators, and or what is the cause of a particular indicator. So this is just basically, we look at the word explore. It's just to try to make sense of information that is given or that we have, to see what else can be done or drawn from the data. So it refers to the critical process of performing initial investigations on the data that we receive, that we don't really have like a clear clue of how to go about doing the analysis. And then we explore the data to discover the patterns, to spot out anomalies, and to test. Maybe we will come up with some hypothesis that we think is, we want to test it out, whether it's logical or whether the hypothesis holds through or not, and to check our assumptions. And we can do this with the help of summary statistics and graphical representations as well. So before, the visualization is not the analysis. Visualization is a tool for us to do analysis. Now we go to the next step, is to make exploratory analysis on the data, which will involve both, like we can use the visual to help us, or we can just look at the raw data and do the exploratory analysis first, then think of what else that can be the visual that can be developed to help out with the analysis. So these two steps don't really need to be like 1, 2. It can go back and forth between visualizing the data and doing exploratory analysis. Next analysis or strategy is trend analysis. So trend analysis is the most general goal is to look if there is a relationship between the data, the level of measure, and time. So we are looking at data over time. Example is to look at the number of children with disabilities versus the time to see and be able to discern whether a given indicator, such as we discussed, the number of children with disabilities, is related to time in a decreasing, increasing, or even if it's like fluctuating up and down, whether there's some pattern in relation to the time. And also trend analysis can tell us how quickly or slowly the increase or decrease occurs through the time or the rate of change over time. So one aspect of trend analysis is to compare one time period to another time period. That is, if we have only 2 points in time, like in as opposed to like year 1, year 2, year 3, and year 4, but then we can also look at a situation as in before and after an event. For example, with the current situation, we can look at the number of people infected with COVID-19 per day before the start of the vaccination being available versus maybe like let's say 1 year after or after at a certain point after people start getting vaccinated. Or we could also look at a person's immunity level before getting vaccinated and after getting vaccinated. This is like before and after. It's a form of trend analysis. Another way is to just expand it to more than just before and after, and then it could be before the first period, at the end of the first period, which would be the before or the beginning of the second period, and so on. So to look at it at like first, second, third, fourth, and so on periods instead of just start and end. Next is estimation. The book used the word estimation, but it could also be viewed as a forecast. And when we say estimation, is because a forecast is never accurate. It's just an estimation or a guess, educated guess of what will happen in the future. So estimation procedures may occur when working with either qualitative or quantitative data. We could estimate or sort of predict what should or what would happen in the future. It could be qualitative sense or quantitative sense. We could also sometimes use both quantitative data and qualitative data together For example, for the Head Start case, we could use poverty level data, which is quantitative, like the salary or like some poverty index, combined with interviews from providers serving low-income families. Then the interviews is the qualitative sense, qualitative data, and combine these qualitative and quantitative data in order to help determine the proportion of families in the area that are income eligible. So estimation is just one way to make a forecast. That could be forecast with using like some mathematical or time series formula, or just some kind of trend analysis that could lead to future forecasts as well. Estimation is just like a simple tool that could be helpful in planning for the future, and it works well for forecasting quantities that are closely related to demographic characteristics, such as eligible children and families and social services. Especially when your data is not purely quantitative, then estimation, taking into account the qualitative um, data, is very useful. So estimation is the combination of information from different data sources to project information not available in any one source by itself. So next, we will talk about key components of data analysis process. Which include purpose, questions, data collection, data analysis procedures and methods, interpretation, identification of findings, writing, reporting, and dissemination, and evaluation. So there are two ways to go about doing the data analysis, which is a full circle when we're talking about the whole process, not just the part of analysis, but what we wrote out here is like from the start of the process, we have to define what do we want to study, what's the purpose, what are the questions, and so on. And there can be two ways to go about this is to do linear approach or to do cyclical approach. A strictly linear approach to data analysis is to work through the components in order from beginning to the end. It's just like a straight line. So the possible advantage of this linear approach is that it's just one way, just going forward. So it's structured and organized because the steps of the process are arranged in a fixed order. There's no going back and forth. There's just like 1, 2, 3. in a linear direction. And thus, like, this would be easier to perform and easier to follow and learn. But then there's a possible disadvantage that the 1, 2, 3, 4, it just doesn't allow us to go backward to do some revision or to do some correction. So it may have some limit on the power of the analyses. In other words, the structured nature of the process limits the effectiveness of the analysis. So this is the chart for the linear approach of that data analysis. Is start from purpose, defining the purpose of the study, then define what would be the question you want to answer, and then start on data collection and perform data analysis and interpret the result and findings from the analysis and start writing the report, making report dissemination, and then evaluate the result. So this one is the linear model. Now, cyclical approach. So cyclical approach is it provides much more flexibility in the nature of decision making. So it's much more flexible, and it can include more and different kinds of decisions to be made because it's not so fixed. So we can kind of go back and forth and revising and adding more of the questions or decisions to be made. Different components of the process can be worked on at different times in different sequences. Is not fixed as in like 1, 2, 3, 4. We can go back to step 2 after step 4 and so on. And then we can also work on many different decisions that are related to each other at the same time. And then in the end, we would just combine everything, like put everything together at the end. So the advantage of this approach is that it's flexible and is not bound, like one staff is not bound to work on each step in order. And so then it's quite flexible and then can just go back and forth. Also, this allows for learning by doing, like as we do things, we learn that maybe we need to correct something, and then it allows us to go back to do improvements. So to ask what approach is better is a bit tricky. It depends. Like, for example, you can say that the linear approach is better in a way that is simple, but to be able to get more insights in a larger scale, maybe cyclical approach is better. but it also requires longer time and more skilled people to do the analysis. So the answer of whether to choose linear or cyclical approach really depends. So this chart shows the cyclical model. Always we just start from purposes, but then we can go back to revise the purpose later. So start from purpose. And then questions. And after this, we could do data collection. It's just following this. And at the same time as, so we do data collection, then we do data analysis. And after data analysis, we try to interpret the solution or the analysis. And if something is missing, we can go back to data analysis again. We could even maybe, if we feel like we're missing out some information, we could even go back to data collection, collecting more data. And we could even go back to questions like maybe we think, oh, data collection, we're collecting something and then we observe some more. That lead us to maybe there are more questions to answer. We can even go here. It's not really fixed to like the arrow here. And then from interpretation, what do the results mean? We get the findings. What do we have to say? Then from here, we write up the report. We do reporting. We do dissemination of the report. And then we evaluate the result. And after evaluation, we could go back to revising, doing like revise our questions, do more, or even go to revise our purposes of doing the analysis, and then just go up to the loop. But it's all what I want to say is it's not really fixated to one arrow headed here. We could even go back from data analysis to data collection, and from data collection to more questions, revision. So just going back to look at each of the components a little bit more. The purpose step is what do we do and why? So this one is mainly looking at the organization or the unit and to see what is the purpose of the task that the organization or the unit is doing. What is the mission? What is the nature of the work? And then to use this as a framework for setting up like the question that the organization want to study with the data analysis on a certain questions or problems or set of problems. Next step is the questions. Setting up the questions means like determining what do we want to know. Before effective data collection or analytical procedures can proceed, one or more specific questions should be formulated. So this would help us to be able to know what sort of data do we want to collect. Without knowing the questions to answer, then we don't really know what to measure or what to collect. The question will also help us to determine what types of analysis would be suitable with the data that we are collecting. The questions may be close-ended, such as, like close-ended mean that the answer would be either yes or no, such as, did the Head Start program meet 10% mandate for serving children with disabilities last year? Or the questions may also be open-ended, such as, how could we do a better job of parent involvement? Then in this case, in the first case, the answer is just yes, no. But then in the second case, we would want like the answer to be sort of like a decision, not a decision, but maybe a plan or like a report with suggestions of what to do. So if you look at the first question, what kind of data will we collect? Probably we will just collect quantitative data with the number, like the statistics. And then the second case, we might need more than just numerical data. We might also need to have some qualitative data, maybe some interview as well. So based on the questions, we can use it to determine and make a plan for data collection process. And this will also help in determining the data analysis process that will follow. The third component is data collection. So this, after we develop the question, we would have to think about what kind of data or information will help us be able to answer the questions. So this would determine what data, measurement, or qualitative data that we need to collect. The data collection process that we need to do or determine is it includes what are the measures, what kind of information we need to collect, and then who will be the source or what will be the source of the data. So this include many dimensions, as in the means, methods of collecting the data. Starting from what is the data? What are the data that we will collect? Then the means of collecting the data and the source of the data. So the source include observations, questionnaires. This is actually the methods. Interviews, documents the test results, and others. And then from each of the methods, some of the methods include the source already, but some of the methods like observation, we have to think, oh, what will we observe? Who will be the source of our observational result? Or questionnaires, who will we ask? Interviews, who will we ask? Documents, what sort of document are we going to get? And then what would be the source? Like which organization, which data, which document, and the test result as well. So the value of carefully selecting the questions to be examined is of major importance, because garbage in, garbage out, if we get a bad data set, then we can't really get a good analysis or a good suggestion out of it. So that means we have to start from the beginning. The question should be worded in a way that would form a good foundation for an effective data collection plan. So we must develop a specific planning process for data collection in order to avoid the common pitfalls for collection process. Some common pitfalls include too little data to answer the question, more data than is necessary to answer the questions, and data that is not relevant to answering the questions. In order to successfully manage the data collection process, programs need a plan that addresses the following. What types of data are most appropriate to answer the questions? How much data are necessary? Who will do the collection? When and where will the data be collected? How will the data be compiled and later stored? So by creating a data collection plan, programs can proceed to the next step of the overall process. In order to, in addition, once a particular round of data analysis is completed, a program can then step back and reflect upon the contents of the data collection plan, and then try to think about what are the lessons learned and what can be improved the next round. So the data collection will include, it starts from the questions, and then the questions will determine what are the sources, what method that we will use for data collection, like who, what, which, when, where, how. And then we do the collecting and compile the data, which would also involve storage. And then we will use these, the data collected, for the next step, which is analysis. The last, then is not the last. The next component is data analysis. So once the data have been collected, we want to try to understand the data to be able to know what is going on. So this is meant by to analyze the data is to find out what is really going on. In a more narrow sense, data analysis is a set of procedures or methods that can be applied to data that has been collected in order to obtain one or more sets of results. Then after the analysis, we will do the interpretation. By interpretation, it means we think about what do the results mean. So we turn to the interpretation of the results. So in some cases, the results of the data would just speak for itself, like doesn't need further interpretation. For example, if we talk about the program's teaching staff, whether they are credentialed, and then if we define being credentialed as having a bachelor's degree, and then the data shows that there's like 100% of the teachers have bachelor's degree, then it just say that is 100% credentialed. Then we don't need to really interpret more. And also, like, if this is the requirement, meaning that if teachers or the applicants for a teacher position is not doesn't have a bachelor's degree, they won't be accepted into the position. Then the data would almost probably all identical with the 100% of the teachers being credentialed. There are, however, many cases when the data from different, like, say, population or different group of data are not identical, then we would need interpretation, like comparison, and then interpreting what does this mean. So example, if the report says 30% of the teaching staff has an AA degree, we don't really know what this means. Then in order to like interpret the data, it involves two parts. First is to present the results of the analysis. And then the second is providing additional information that will allow others to understand the meaning of the results. So in other words, by interpreting is to make sense or to say what the meaning is. What does the result mean? So interpretation will involve both decision making and the use of good judgments. By results, it means any information obtained from using analysis procedures. And we use the term findings to refer to results which will be agreed. So the next component is writing, reporting, and dissemination. What do we have to say? How do we tell the story of our data? So after getting the interpretation, then you have to be able to present what you have analyzed, what you have interpreted. So this could be done by writing, reporting, and dissemination of the result. And the best way is to think of how you will tell it as a story. So the good writing should be structured to provide information in a logical sequence that is easy to understand and follow. This means that a good writer should be strategic and use a variety of strategies to structure their writing. One strategy to be used is to have a purpose for the written work to be clearly and explicitly laid out. The next aspect of good writing is taking the audience into account. Like, who are your audience? And then write it in the way that it would make sense to them, or they would be able to understand. What would be their interest? How would your report capture their interest or make them able to follow you? And the last is just what I have said. The best way is to think of it as telling your story. Use the data. How do you tell a story of the data that you have collected, analyzed, and interpreted? Then the next component is evaluation. Evaluation is to evaluate what have been learned about the data analysis process that have been completed. So they can review the data analysis that have been completed and then reflect upon, does it really support the purpose? Was the data analysis process consistent with the purpose of the organization, such as federal standards for the Head Start case, federal standards, and other relevant regulations? Evaluate the questions. Were the questions worded in a way that was consistent with the federal standards, other regulations, and organizational purposes? Were the questions effective in guiding the collection and analysis of data? Evaluate the data collection. How well did the data collection plan work? Was there enough time allotted to obtain the necessary information? Were data sources used that were not effective? Do additional data sources exist that were not utilized? Did the team collect too little data or too much? Data analysis procedures or methods. Which evaluation? Which procedures or methods were chosen? Did these methods or procedures conform to the purposes and questions? Were there additional procedures or methods that could be used in the future? And then to evaluate the interpretation or identification of findings is to think and evaluate whether how well did the interpretation process work? What information was used to provide a context for the interpretation of the results? Was additional relevant information not utilized for the interpretation? Did team members disagree over the interpretation of the data, or was there consensus? So all these evaluation is to help us think in terms of quality of the data analysis that has been performed, whether there is good, did it go well, should something be improved. Next is evaluating the writing or the reporting or dissemination. This is to answer the questions, how well did the writing tell the story of the data? Because after all, what we want to do is the keyword is to tell the story of the data. So how do we evaluate how well it is? By thinking or evaluating whether the intended audience really understood or absorbed the story that we told. Did they get it? Did they really follow the story? Did they find the presentation effective? So in sum, the data analysis is a process which is a series of connected activities designed to obtain meaningful information from data that have been collected. As the graphics demonstrate, the process can be conceptualized in different ways. It could be linear or cyclical. Which approach is better? It just depends on situations. And each stage in the process involves decision making. Which decisions are made will then influence the remaining stages of the process. And then later on, I want you to log into Google Classroom for the quiz and then submit it with before the time announced in Google Classroom. Thank you.